A very good evening to everyone present here. I am Pooja Rao, a technical team member of Phoenix Aero. I am from Mechanical Engineering Department and I am from Vadodara, Gujarat. So today we are here for our Aero Plus event, that is a 10-day event, the Aero Modeling Workshop, which will be held by the student chapter of SVNIT, Phoenix Aero SAE, the Society of Automotive Engineers. So our today's session the aircraft introduction, and our session will be taken by the technical member of Phoenix Aero, Nupur Subodh Kulkarni. And I hand it over to Nupur. All the best.
Thank you, Pooja. So, hello everyone. Good evening. Let's start with our first session. It's about aircraft introduction and basics. So, before starting our session, let's see what are the session objectives. After completion of this session, you will be able to understand how aircrafts have evolved, distinguish between different types of aircrafts and their abilities. We'll be able to comprehend what kind of forces act on an aircraft, how they maneuver, and also understand different components of the aircraft along with the control surfaces. So let's start with a very basic question. Can you name some objects which can fly? Like you can speak up by unmuting yourself.
Butterfly or airplanes.
Drones and aircraft.
Most of you answered drones and helicopters, hot air balloons. Yeah, one of you answered birds. So that was the one which I was looking for. As you can see on the screen, it's birds, aircrafts, airplanes. They are some objects which we see they fly. But let's start with the very basic concept. Many aero enthusiasts, they actually got inspired by this special capability of birds to fly. Thus, they did many experiments from pre-Wright era up to the successful Wright brothers flyer. There has been enormous evolution of aircrafts. This on the screen, you can see the first image is about it's the first ever flying machine, which was made by Sir George Cayley. It is probably considered to be the first flying machine which illustrates a discrete fuselage, wings, and empennage. The second one is the biplane, which we all know it is invented by Wright brothers. So we consider these biplane, this biplane as the soul of how our aircrafts evolved and how today we see. We think that this is the main aircraft from which our airplanes, which today we see, they got evolved. Another basic question I have is, which was the first ever aircraft to fly? Like you can put up in chat box or speak up.
Plane that was made by Wright brothers.
No. We'll come to this confusion. Like I'm asking that which was the first ever aircraft to fly? It's Flyer 1. Like, are you saying it's the Wright brothers Flyer only? Flyer 1?
Yes.
Wright Flyer. Oh, okay. So the actual answer to this question is the airship. The first ever aircraft, long before even many years before the successful testing of Wright Flyer, it was the airship which was the first ever aircraft to fly. So you might have wondered that I am using the word airplane and aircraft here. So can anyone tell me that in Ravana's flight was the first? Okay, if we dig a little deeper into that, then yeah, you can say that it was the first aircraft. Nice one. Okay, yeah. So like as I'm using the word aircraft and airplane, what do you think that are both same or different?
Different.
Different.
I suppose they're different.
Aircraft are aircraft are machines that can fly. An airplane is type of aircraft.
Heavy subset type, like airplane is
Okay,
subset
you
of
are pretty
aircrafts.
close. You are close to this, yes.
They are different. Airplane is actually a type of aircraft in which the wings are fixed. They are fixed.
Okay, that was the right one. That airplane is a subset of aircraft and it has fixed wings. So let's clear out the confusion if anyone is having. As one said, that airplane is a subset of aircraft. We can consider any flying machine as an aircraft, but an airplane is one which is heavier than air, which is power driven and has fixed wing. As someone said, it should be fixed wing. Along with that, we have two criteria. It should be heavier than air. Like it should not just float in air. It should be heavier than air. It should be power driven. So now we'll see a basic classification of the aircrafts. We have two systems, LTA and HTA. LTA system means it has lighter than air type of aircrafts, and in HTA, also known as Aerodynes, we have heavier than air type of aircraft. LTA systems are one which moves slow and they are more susceptible to the weather changes. They consume less fuel. However, the Aerodynes, the heavier than air type of aircraft, they move very fast. They can achieve great speeds. They are less susceptible to weather changes, and but they consume more fuel. Now, my motive to have such classification is most of the aircrafts which we see flying in sky, like it can be military aircraft, cargo aircrafts, passenger aircrafts, they are termed under the aerodynes. They are heavier than air. And the airship or the hot air balloons which we see, they are termed under LTA systems. That is lighter than air. Now there is one question for all of you. Where will you term kite? Like, where will you group kite? Is it lighter than air or heavier than air? What do you think?
Lighter than
Lighter than air.
I'm lighter than air.
Lighter than
Like,
air.
Lighter than air.
heavier than air.
No, heavier होगा.
Consider you are holding a kite, and means you are just holding it. You haven't tied it with any thread or something. You let it go off from a height. Does it float in the air or it comes down? What does
It
that?
floats for a while.
Ma'am, it
Comes
depends on the
down.
wind velocity.
They are on the right track. It's true. The kite is something which comes under aerodynes. It's heavier than air. Like just imagine you're holding the kite and you just let it go. It will automatically come down. It's not going to float as if like the objects float on water due to buoyancy. It's not going to float in the air. That is categorized under aerodynes. Now, as our main domain of interest is about the heavier than air type of aircrafts, we'll see further classification of that. These are classified based on the power, like non-power driven and power driven. Kite, as we just saw, it comes under heavier than type non-power driven aircraft. Now, for those who haven't seen gliders, like glider is also looks like an airplane, but it doesn't have inbuilt power system. It is like it is either attached with another aircraft and then it is let it go from a altitude. Now, under power driven, we have fixed wing airplanes, which we see like the cargo ones, passenger ones, helicopters, and we have UAVs. Now, as we deal with aero modeling, like designing the aircrafts, One of the important aspects while designing is the purpose. For what purpose are we going to use that aircraft? So based on that, we ourselves have categorized this as into these four. First we'll see the military type. Military aircrafts are designed in such a way that they can attain high speed and they can go to high altitudes, they can achieve high altitudes, and they can do intricate maneuvering. Now, the image which you are seeing, it's the stealth bomber, it's the American heavy strategic bomber, which was purposefully designed during the Cold War for penetrating into dense anti-aircraft defenses. The next we have is cargo. Like cargo aircrafts are such, they are designed to carry heavy payload. They are designed to carry large, huge cargoes, like your vehicles, automobile parts, even heavy objects like the wings of an aircraft are also carried through the cargo airplanes. Now, can anyone name what is the name of this?
Beluga.
Ma'am, Antonov.
No, someone answered it right. It's Airbus Beluga. It is specially designed in such a way so that it can carry the blades of turbine and windmills. Also, wings of many heavy aircrafts are carried through this cargo airplane. Then we have agricultural type. These are mainly used for spreading pesticides and for doing agricultural surveys. Next, we have passenger aircraft. Like passenger aircrafts are such which carry passengers, like they have pilot, they have people on board. And the main purpose while designing a passenger aircraft is they should carry maximum amount of maximum passengers in them. So now another basic question: what is the full form of UAVs?
Unmanned aerial vehicles.
Unmanned aerial vehicles. Okay. So now till now we saw a difference between airplane and aircrafts. Let's differentiate between what an airplane and a UAV is. So UAV, as someone said, it is unmanned aerial vehicle. So we are not having any pilot or anyone on board who is operating the airplane. However, airplanes are such they can be termed they can be termed under UAV if they are radio controlled, or if they are controlled by some. Means they are not having any pilot or any people on board for controlling them. Like the first image which you can see, it's the first ever RC aircraft which was designed by our club. It is the Pegasus. It was a trailer of the club, and it is a UAV. The next image you can see, it is a drone. So commonly we mistook drones as UAV, just drones as UAV, but RC controlled RC airplanes are also termed under UAV. So now we'll see broad classification of these UAVs. As our club is more inclined towards the towards the aero modeling and manufacturing related to UAVs, so we'll see the classification of UAVs. Based on landing, we have three types: VTOL, HTOL, and STOL. VTOL means it is vertical takeoff and landing. In this, the aircraft is going to take off vertically. Like for example, drones, helicopters, multi-rotors, they don't need a runway for takeoff and landing. Now the next we have is HTOL. It is horizontal takeoff and landing. In this, we need some space. We need a specific runway for the airplane to take off and to land. So a differentiating factor which we can see is wherever less space is required, there we can implement VTOLs. All the passenger aircrafts, yeah, most of the passenger aircrafts, they come under HTOLs because they take off horizontally through a runway. Now we'll see STOL. STOL means it's short takeoff and landing. There are certain regions and where we cannot build such a big runway which we have on our international airports. So there, especially STOLs are utilized. Common application of STOL is basically seen in military for military purpose. Like for military purpose, we can't build we don't have actually a big space which is fully dedicated for the runway. So for that purpose, we mainly implement STOLs. Now, based on aerodynamics, we have fixed wings. Like here, the fixed wings doesn't mean that the wing is actually, it is fixed, means it is rigid. It means that the wings are not rotating, they are not moving with respect to the fuselage, the center body of the main body of the airplane. Next, we have ducted fans. In ducted fans, the propellers are actually, they are kept, we can say they are ducted inside a cylindrical body, and they provide greater amount of thrust. So most of the aircrafts where more thrust is required and it is feasible to implement a ducted fans concept, there they can use this. Then we have multi-rotors, like drones. The drones come under the multi-rotor section. In this, the propellers, also known as rotors, they are the most important part because they are actually generating the lift because of which our aircraft is going to perform the tasks. Next, we have ornithocopter. Ornithocopter is, we can say, it's an aircraft which imitates birds. Like even you can see in the image, it is based on such mechanism. It is actually based on the flapping wing mechanism, in which like lift is generated when the wings are flapped. Thus, it is trying to imitate the birds. Yeah, it is. It was used in the surgical strike. Yeah, the film Uri. We all have seen this ornithopter in film Uri.
And I also got to know that they use it at airports to keep the birds away from the runway.
Yeah, that there also we can see its application. Okay. So till now we have seen a broad classification of airplanes and aircrafts. Now we'll see what are the major forces acting on an aircraft. So can anyone answer if they know?
Drag,
Thrust and
lift,
drag and
Drag,
lift.
drag force.
Drag, lift, thrust, and
Lift.
weight and lift.
How come you forgot the gravity?
Yeah,
Weight.
Yeah, the weight is also there.
lift.
Right, most of you have answered correctly. So let's see one by one. First of all, gravity. Gravity, it's acting downwards because of the weight of the aircraft. Then we have thrust. Thrust is a kind of, it's a forward pushing force which is actually generated because of certain propellers or thrust producing devices which are installed on our aircrafts. Most of the time we have propellers for it. Then we'll see lift. Lift is actually generated because of the pressure difference which is observed above and below the wing. Now, lift will be actually seen in detail in our next session. Now we'll see the drag. Like drag it can be considered as a resistive force which is acting on this aircraft. Is actually opposing our forward motion, the cruise motion, which is actually occurring because of thrust. So these are the four basic flight forces acting on an aircraft. Now we'll see parts of an airplane. So first of all, Can anyone name what is fuselage? Like mostly we know
The
what is.
long, the long portion of that plane, the hollow
Right,
cylinder.
right. It's hollow cylinder. Okay. Now, in the image which you can see, it's a conventional passenger aircraft. In that, the place where passengers sit, where they are going to sit, that is the fuselage. So we can see the main body of an aircraft is the fuselage, of an airplane is the fuselage. Then we have wings, which are lift generating devices. And at the trailing part, we have empennage. It is the tail. So these are the main components of our plane. We have different control surfaces also in order to gain stability and control. Now now we'll see these control surfaces. Like you might have wondered that wings are there for producing lift, for generating lift, but we need certain elements, we need certain components which will make our aircraft stable, and it will help our aircraft to change the direction. So let's start with the control surfaces. Before starting with control surfaces, I would like to introduce with three axes. The axis which is acting along the fuselage, parallel to the fuselage, it is termed as the longitudinal axis. The vertical axis, we have a vertical axis, and the axis which is along the wing, that is the lateral axis. Now let's see the functioning of ailerons. Ailerons are actually considered as primary control surfaces, and they controls the rolling motion. As you can see in the animation, as the ailerons are deflected in opposite direction, this rolling motion can be achieved. We can see that this motion is actually achieved along the longitudinal axis, the axis which is acting along the fuselage. The next control surface which we'll see is the elevators. Elevators are installed on the horizontal stabilizer. This horizontal stabilizer is a part of empennage, tail. When we deflect elevators, it leads to pitching movements. Like it is a movement which occurs about the lateral axis, the axis which is along the wings. This is pitch up, pitch up, and this is pitch down motion. This pitching moment can be achieved using the elevators. Now we'll see rudder. Rudder is incorporated on the vertical stabilizer. It is responsible for the yaw motion, and this yaw motion takes place about the vertical axis. Like consider this is your rudder, and you are like you want to yaw towards, means you want to yaw towards this right direction. So for that, the force must act on this. So for that, your rudder will move in this way. The force will act like this, and our aircraft will move towards the right. That it has yawed towards the right side. Here in this image, we can see the recap of all these three motions. The ones which are deflected now, these are the elevators, and they lead to the pitching motion. The yellow colored is the rudder. As based on the movement of rudder, we can change the direction of aircraft. That is, we are going to yaw the aircraft. Till now, we have seen all the forces and basic classification, basic elements regarding the aircrafts and airplanes. But there are certain limitations of airplanes. Certain altitude limitations are observed when we cruise an airplane. Also, airplanes cannot stop in between the flight. They can't levitate as the drones do. So these drones are multi-rotors. They can overcome these problems, and thus we have termed drones as future of aero modeling. Drones make various applications easier for us, like it may include surveillance, mapping, and any rescue and security operations. Even commercial deliveries are done nowadays using drones. So we'll see drones now. Based on the number of uh, based on the number of rotors, we have different classification of drones. Like if we have 3 rotors, then it is termed as tricopter. 4 rotors, then it is termed as quadcopter, and 6 rotors, it is termed as hexacopter. Propeller blades, also known as rotors, they are the most important part of the drones because they are responsible for generating the lift. Now, for basic analysis of the physics behind motion of drone, we'll analyze a quadcopter. This is a quadcopter which you can see on your screen. In this, can anyone answer why the rotors 1 and 3 and 2 and 4 means the diagonally opposite pair are rotating in same direction? Can anyone answer?
So like if we don't do that, it will rotate in like the a whole setup will rotate in one direction.
To provide the
To
balance.
balance the torque, I guess.
To balance the torque.
Yeah.
Like, if we don't means if we rotate all the propellers in one direction only, then what will happen?
The
It
whole
will go
system will
unstable.
become
will rotate about itself.
unbalanced. It will be an unstable system.
Whole system will stand still and it will rotate at the same axis, same point.
Yeah, it might flip.
Okay, it will rotate, that's true, but let's see. Let's dig a little deeper into this. Consider if all the rotors, all these 4 rotors are rotating in clockwise direction. Then, because of Newton's third law, we all know that what is Newton's third law? It involves action-reaction pairs. So as each of our propeller is rotating in clockwise direction, the drone will experience an anti-clockwise torque. It will experience an anti-clockwise torque. And thus, it will start rotating in an anti-clockwise direction. So instead of having a stable flight, it will rotate about the vertical axis like this. So to avoid such kind of rotation, we are actually means to gain stability and avoid such kind of rotation, most of time we rotate the diagonally opposite pair of propellers in same direction as shown in the figure.
Ma'am, this can't happen in 3 rotor formation.
Can you repeat?
This thing that drone is rotating anti-clockwise thing, can't this happen in 3 rotor formation?
Yeah, Nupur, let me answer this.
Okay.
Okay. You are right. Like this can happen in tricopter. You are saying about tricopter. Okay. So in tricopter, there are 2 ways to avoid this. So first way is like we can increase the propeller size of a one motor and compensating that torque by other 2 rotors, or we can add a servo that can rotate the arm, one arm or 2 arm of the tricopter and balance the torque. Okay, so it's like more complex, but yeah, good question.
So yeah, the actual that means similar mechanism as Meg said. Similar mechanism is seen in tricopters also, but it is somewhat difficult to analyze. So for
Ma'am,
basic concept, we went with this. Yeah,
ma'am,
yeah.
ma'am, in the quadcopter, if we have 1 and 2 to spin in one direction and 3 and 4 to rotate in the other direction, then also the system will remain unstable.
Yeah,
Yeah.
yeah. One more good question. You also said, the rotating problem will solve that will solve the that will balance the torque. But while doing forward motions and maneuvers, that will hinder the system. Like if I want to go in a particular direction, like you are saying that I want to go in the direction. Okay. Okay. Now let me explain. Okay. 1 second. So suppose 1 and 2 are rotating in the same direction. So I will just put this will rotate in this direction, okay, and this will rotating in this direction. So this will generate a problem when drone want to go forward. So for going forward, this both must have this both should decrease their speed, and this both should increase their speed. Okay, right? If I want to go forward, this both should decrease the speed and this both should increase the speed. If this will increase the speed, then while going forward, the net torque will increase in this direction, right?
Yes, yes.
But instead,
Yes.
if I will do the cross configuration, then this both will increase the speed and this both will decrease the speed. So that will eventually balance out the torque while moving forward or doing any maneuvers. So we must remember that while making a drone, we should imply a symmetric system for doing a 360 movement of the drone. This is not for only quadcopter. This is applicable for any quadcopter or hexacopter. Okay.
Okay, okay, got it.
सर 1 और 3 के रोटेटर के स्पीड और 2 and 4 के रोटेटर का स्पीड क्या डिफरेंट हो गए या सेम होंगे? यदि सेम होंगे तो फिर तो लिफ्ट या फिर मूव फॉरवर्ड तो हो ही नहीं पाएंगे.
सॉरी
सर जैसे 1 और 3 के
सारे रोटेटर्स की जो स्पीड है वो सेम होएगी क्या एक टाइम पे? मतलब सेम होएगी तो फिर कैसे होगा?
अरे नहीं, ऐसा नहीं. ओके ओके, यू आर लाइक कंफ्यूजिंग इट लाइक नाउ. सपोज we have to balance both the things. We have to balance the weight, we have to balance the net torque, and we have to do the motion also. Okay, so for balancing the weight, if these both rotators will decrease the speed, this must increase the speed to balance the weight. Okay, right?
यस सर.
ओके, तो मतलब जैसे सेकंड और फोर्थ की स्पीड सेम होएगी एक टाइम पे?
हाँ, फर्स्ट और सेकंड की स्पीड सेम होगी एक टाइम पे. They will balance the torque of each other, and for countering the weight, these two propellers will act.
अच्छा, और ऐसा नहीं हो सकता कि सेकंड और फोर्थ की सेम हो और फर्स्ट और थर्ड की सेम
हाँ,
हो?
सेकंड और फोर्थ की सेम हो और फर्स्ट और थर्ड की सेम हो.
हाँ.
मतलब वो तो जब सेम होगी तो फिर क्या ही मोशन होगा? कोई मोशन नहीं होगा. वो अच्छा वो ओके 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 दैट ओके. Now let the complete the session of this drone. On the next slides, they are going to explain this. Okay.
Now we'll see basic motions of a drone. First of all, we'll see the climbing. In this, the propellers are rotating and thus they are producing thrust. If this lift generated by the propellers is greater than the weight of the drone, then the drone will move up. So it will move upwards. The next we'll see is pitching moment. And consider in this that the drone is pitching towards you, like it is pitching towards the screen. So to make a drone pitch forward, what we need is we have to increase the power applied to the rear motors. Now in this, the red arrows which you can see, there the power applied to the motors has been increased, and thus the drone will pitch forward, like it will pitch towards us. This generates a forward net force which makes the drone's nose to pitch downwards. Like when it is pitching towards us, it is going to tilt. Like consider this drone is coming and it is going to tilt. Also, we have to keep in mind that while we are increasing the power on the rear motors, the power on the propellers which are forward, it has to be decreased. This decreased amount can be shown using the blue colored arrows. The next we are having rolling motion. In this, if we want to roll our drone towards left, if we wanted to roll towards left, like I'm considering this rightmost image, So if it wants to roll towards left, then the lift has to be increased on the motors which are on right side. Like it should be on the opposite side. The drone must also decrease the lift on the motors which are situated on the left side. So these can be seen through the arrows. These are depicted through the arrows, that the lift which is generated by the propellers at the right side, like the red colored arrows, it is more. Similarly, we can apply when we want to roll towards the right. Like if we wish to roll towards right, then the exact opposite of this has to be done. The lift is increased on the motors which are towards the left, and the drone must also decrease the lift on the motors which are on the right side. So now next we'll see yaw motion. In this, to make the drone yaw means it is going to rotate about the vertical axis. Like consider as given in the diagram, we'll consider that it is rotating in clockwise direction. To make the drone yaw in a clockwise direction, we need to increase the lift on the rotors which are moving in anti-clockwise. We need to increase the lift on the rotors which are moving in anti-clockwise. Thus, in this, the propellers whose lift is shown by red color, their lift has to be increased. Side by side, we have to simultaneously we have to decrease the lift which is because of the propellers moving in clockwise direction. Like what we are doing, like we want to yaw it in clockwise direction. Okay, we want to yaw the drone in clockwise direction. So for that, the rotors which are moving in anti-clockwise direction, on them the lift should increase. But simultaneously, the lift which is because of the rotors moving clockwise, there we should decrease the lift. So when we achieve such situation, then we say that our drone has yawed, it has rotated in a clockwise direction. The reason behind this is to keep both the upward and the downward net force which is acting equal to 0. The drone rotates clockwise as we are making such differences in lift. It actually rotates clockwise because of the third law. It is because of the angular momentum, actually, conservation of angular momentum. We can also analyze this using the Newton's third law. This is a question of the day for all of you to think. Like, as we have seen, most of the drones have even numbered rotors. They have even number of rotors. So think a little about this. Like why most of the drones which we use, mostly even number of rotors are preferred on them.